Okay, welcome to this introduction to hexadecimal. I'm Ben from Master Computer Science. Okay, so hexadecimal is a number system that can represent or has 16 symbols, so it can represent the numbers up to 15. The most common question I get when teaching hexadecimal is why do we bother? Right. So if you haven't already watched the introduction to binary, go and watch that first of all. Essentially, if you're trying to write down a number of binary numbers, if you use a nibble, which is 4 bits, and we turn all of our 4 bits into the number 1, and then we put in the values along the top here, we can see we've got 8 plus 4 plus 2 plus 1, which gives us 15. Okay? If, alternatively, we say we're going to put in all zeros, then we've got 0 plus 0 plus 0 plus 0, which gives us 0. So, with 4 bits, with what we call a nibble, you can represent the numbers 0 all the way through to the number 15 with binary. Hexadecimal can represent every number from 0 to 15. The way it does this is if we just put the denary numbers here first, hopefully these will all fit in. I need a taller whiteboard. This is tricky to get down here and right. Okay, so these are our denary numbers. Everyone's familiar with these. If you're in the USA, you don't call them denary numbers, you call them decimal numbers, and that's starting to become common over here in the UK too. Right. So let's call them decimal. These are our decimal numbers. Our hexadecimal numbers for the first 10 symbols are identical. Now, there we go. Up to 9, no calculations needed. Anyone can understand those. If you can't understand those, you really don't want to be learning hexadecimal. It's going to be a bit more complicated for you than other people. Okay, when we get to 10, rather than representing it as 10, or in binary that would be 0, 1, 0, 1, 1, 0, we represent it as A. 11 is B, 12 is C, and so on. Okay. What this does for us as computer scientists is give us characters F which can represent the number 15 rather than what we'd see in binary. Let's just plug those in. Now, let's see if I can get this right. I don't think I've ever once drawn these all in correctly. 0's easy. Okay, so all I'm doing here is representing these numbers in binary numbers. Let's see if we can get it right. 5, 6, 4 plus 2 plus 1 is 7. Okay, so far so good. Oof. Can I make it all the way to the end without an error? 1, 0, 0, 4, 8 plus 4 is 12, plus 1 is that. 1, 1, 1, 0. Yes! Smashed it. There we go. So, rather than memorising these nibbles, which even for an expert like me, you can see is a bit tricky, we can just use A, B, C, D, E, F. Okay? In the early days of programming, you'd have two programmers. One guy would be reading off a list of binary numbers, maybe something like this. Okay, so one guy would be sat there going 0001, 0101, 1010, 1111, and there'd be another guy typing these in, or changing the logic gates so they met this. One error and your program doesn't work. It's a lot easier to go, right, 0001 equals 1. 10101, 01 equals 5. 1010, that's A, and 1111 is F. So rather than reading out all of that, we can represent that as that. 15AF. Okay, a lot simpler. If you go into web design or talk to any kind of graphic designer, they will use these all the time. Your computer can represent red, green and blue. So the colours that make up all other colours on a computer screen, these are obviously different from the primary colours you learn in art and so on. And I can then say, okay, so each of these can have two hexadecimal numbers. Now each hexadecimal number represents a nibble. 2 nibbles is a byte, the standard number system size for computers. So let's say we use this 15 AF, and then let's say blue is A1. Okay. That then tells me what, actually I'm going to need a bit more space for this one. That then tells me what number each of these are. Okay, rather than memorising it all. And those numbers represent how much colour is in that thing. So say this is the background for a website. Let's see what colour we've got. So red equals 15. Right. So I split that and I do the nibble for 15, for 1. Okay. Then I do the one for 5. Okay, then I get that out of the way. And I can represent this just like a normal binary number. And I go, those two are going to be difficult for me. 1, 2, 4, 8, 16, 32, 64, 128. Okay, so I'm adding together the numbers with the 1 underneath them. 16 plus 4 plus 1. So I've got 22 red. So I haven't got a lot of red. Right, G equals AF. So I split that in two. A is 10, so I go 1, 0, 1, 0. F is 15. Okay. Then I plug it in as a byte. 1, 2, 4, 8, 16, 32, 64, 128. And I go, well, I know this end is 15, so I'm going to go 8 plus 4 plus 2 plus 1. I've got 15 there because I've got that memorised. This one's a bit trickier. 128 plus 32. Right, so I'm going to have 30. So that is 160 for these two, plus 15 gives me 175. Okay, so there's quite a lot of green in there. Right, so blue is A1. Now, I'm going to simplify this for myself. I know what A is, I've just done it. It's 128 plus 32, so it's 160. So I can just put that there. I know that the denary for 1, once I do all this, is going to be 1. Okay, so I've got 161. Okay, so quite a lot of blue. So we've got this turquoisey colour with a little bit of red. If you look at this as well, you can see that the maximum you can represent here, the maximum number represented by any byte is 255. So that's how many colours your computer screen can represent. There's a bit more complicated than that, but as a general rule of thumb, that's usable. So anything up 175, 161, we're close to our 255. We're close to it. Obviously, anything near 0, like the 22, we're not using a lot of it. And that's essentially hexadecimal, how it's used, how to convert it into a binary number, and then if you've watched the previous video, you'll know how to convert a binary number back into denary or decimal. Okay, thank you very much everyone.